Hi students, in previous session, we discussed some previous year questions in JEE Mains on gravitation, and also we discussed some synopsis related to this. In this session, we discuss some more questions related to the gravitation which are given in previous years in JEE Mains sessions. We go for the next question. This question is, the planet takes 200 days to complete one revolution around the sun. If the distance of the planet from the sun reduces it to 1/4 of the original distance, how many days will it take to complete one revolution? This is a simple application question related to Kepler's third law, which is law of time periods. The square of time period of a planet is directly proportional to cube root of the distance between planet and the sun. From this, I can write T1 by T2 equal to R1 by R2 to the power of 3 by 2. And your problem, T1 is 200 days. You ask it to find what is the value of T2. And R1, let us consider initial distance of the planet is R. And R2 is, it is reduced to 1/4, that is R by 4. So this becomes 200 by T2 equal to R divided by R by 4 to the power of 3 by 2. 200 by T2 equal to 4 to the power of 3 by 2. This is equal to 8. Then we get T2 equal to 200 by 8, 25 days. So this is your answer. We go for the next question. The problem is, at what distance above and below the surface of the earth, a body will have same weight. The radius of Earth is given by R. We know the weight of a body is m into g. Mass is constant. The weight varies with z. You ask it to find at what height as well as at what depth, at this position and this position. The weight of the body is same. The weight of the body is same means the value of g here and here both are same. We have to find what will be the value of h. Now, at some height h, what will be the value of g? Suppose if I take g prime, this is the value. Then what is the value of g prime at height h? Yes, it is g into r square by r plus h whole square. Similarly, at depth h, g prime equal to g into 1 minus h by r. And according to your problem, these two values are same. That is g into r square by r plus h whole square. This is equal to g into 1 minus h by r. These two will get cancelled. Now, you simplify this to get the value of h. If you simplify it, you get the value of h is root 5r minus r by 2. This is your answer. At this height, both the values of g are same. That is, the weight of the body is same. We go for the next problem. The acceleration due to gravity on Earth's surface is g. The diameter of the Earth reduced to half of its original value and mass remains constant. The acceleration due to gravity on the surface of the Earth will. It is given the acceleration due to gravity on surface of Earth. It is G, and we know that the value of G is Gm by R square, where G is universal gravitational constant, M is mass of the Earth, and R is the radius. And you ask it to find what will be the new value of G. The diameter is reduced to R. The diameter is reduced to R means radius also reduced to R. And the mass is constant. So what will be your new value? G prime, let us consider. G, M is constant, R by 2, yes, whole square. Now this is equal to, you get 4Gm by R, 4Gm by R square. This is 4G. Now this is your answer. Suppose in the same problem, if I ask, what will be the acceleration due to gravity if the diameter is reduced to half? Only the diameter is reduced to half, and I have to discuss about the mass. If I ask, the diameter is reduced to half, can we say mass is constant? No, it's not constant. In that case, how to do this problem? Yes, in this case, we have to consider mass density is constant instead of mass. So for that, I take G equal to Gm by R square. G into, instead of M, you write volume into density. Density into volume divided by R square. So this you get 4 by 3 pi G rho R. That is G proportional to R. G proportional to R. The radius, that is diameter reduced to half, radius reduced to half. Then G becomes G by 2. Yeah, if mass is not constant, like this you have to do. If mass is constant, this is your answer. We go for the next problem. Two identical particles, each mass m, go around a circle of radius a under the action of their mutual gravitational attraction. The angular speed of each particle will be. Now, what is given in your problem? Two identical particles. They are moving in a circular path of radius a. From here to here, it is a. So, what is the distance between these two particles? Yes, it is 2a. You ask it to find what will be the angular velocity if they are moving in a circular path. We know that the gravitational force is the centrifugal force here. And when this particle is moving, the centrifugal force is mr omega square. Here the condition is mr omega square. This should be equal to gravitational force between the particles. Here R is 2a. So you can write it as mr omega square. This is equal to Gmm. Instead of R, you write 2a square, that is 4a square. Here also R is 2a. Gets cancels. Now I get omega square equal to Gm divided by 8a cube. Angular velocity omega equal to root of Gm divided by 8e. Now this is your answer. We go for the next problem. Two planets A and B of radii r and 1.5 r have the densities rho and rho by 2 respectively. The ratio of acceleration due to gravity at the surface of B to A is. Already we know that the acceleration due to gravity on a planet is given by Gm by R square, or in terms of density, G equal to 4 by 3 pi G rho R. That means G proportional to R from this, as well as G proportional to density. Now you ask it to find the ratio. And in your problem, it is given planet A and planet B. For planet A, this is, you can write it is RA rho A divided by RB rho B. And this is equal to R into rho we take. This is 1.5 R into rho by 2. R will get cancelled, rho will get cancelled. Now finally you get it is 2 divided by 1.5, or this is 4 by 3, because 1.5 is 3 by 2. So this is your answer, option D. And we go for the next problem. The next problem is a planet having mass 9 m0 and radius 4 r0, where m0 and r0, these are the mass and radius of Earth respectively, has escape velocity in kilometers per second is given by. Yes, directly you know the escape velocity. What is the expression for escape velocity? The escape velocity from a planet, I think already you remember this, root 2gr, or this is equal to root of 2gm divided by r. Now let us consider VE is the escape velocity for Earth and V is the escape velocity of another planet. Now this equal to, as G is constant, mass and radius are not constant. Yes, you can write it as square root of, it is directly proportional to root of mass, where ME is the mass of the Earth and MP is the mass of the planet. And this is, now in our problem it is given, the mass of the planet is 9 mg and the radius of the planet is 4 re. Yes, and square root. ME, RE gets cancels. Then BE by BP, this is equal to root of 4 by 9. This is 2 by 3. So escape velocity on planet is 3 by 2 of escape velocity on Earth. This is 3 by 2 into, this is 11.2 into 10 power 3. This is the escape velocity on Earth. So just to simplify this, what you get? Yes, you get this around 16.8 into 10 power 3 meters per second, or 16.8 kilometers per second. Option B is your correct answer. Now we go for the next problem. Two satellites A and B move around the Earth in the same orbit. The mass of A is twice of mass of the B. The quantity which is same for two satellites. This is very simple question, seems to be, but so many students do mistake. Can you guess the answer? Yes. See here, when a satellite is moving in an orbit, this orbit has a particular speed. The speed of that orbit is given by V equal to root gr. This is called parking orbit. It depends on the distance of the orbit. It not depends on mass. While you take kinetic energy, potential energy, or total energy, all these depends upon mass. So for these two satellites, A and B, What is same? The velocity or speed is same. Option A is correct answer. We go for the next one. A spaceship of mass 2 into 10 power 4, 10 power 4 kg is launched into a circular orbit close to the Earth's surface. The additional velocity to be imported to the spaceship in the orbit to overcome gravitational pull will be. The radius of the Earth is given as 6,400 kilometers and the value of G is given as 10 meters per second square. Already we know that when a satellite is moving near Earth orbit, the velocity is root gr. And what is the escape velocity? Yes, the escape velocity is root 2gr. That means the additional velocity required to escape this satellite from this orbit will be, it is root 2gr minus root gr. Is it correct? Yes. Now this is the additional velocity required. Already it is having root gr velocity. This is the additional velocity we have to give. To take root gr is common. It is root 2 minus 1. It is the answer. Now the question is, some of you know that root of gr, that is, root of gr value is 7.9 kilometers per second. Yes. Now can I take this option is correct? No. Why? Because we get root gr is 7.9 if I take the value of g is 9.8 meters per second. But it is given the value of g is 10 meters per second square. So you substitute it. Yes, definitely we get this value is 8 into root 2 minus 1. This is your option. This one is your answer.